Okay, we're going to move on here. So make sure you've got the previous program open. We'll keep, for now anyway, every program we create, we'll keep those two lines on there. So if this is a complete new program you're working on, you can either type them in or go and copy them from your old program. So essentially every one that we run from now on, we want to have at least a message at the end that says press any key to continue, followed by a read key. And this one here, I'll just change the right line to a right so that the cursor does come up at the end there. So when I run it, it looks more like that. So in all programming languages, they all make use of basically memory locations. In other words, they need to store information and store information temporarily. It might be used for calculation, it might be used to display something on screen, but whatever it is, the computer needs to be able to store it. And one of the most basic types of memory storage facility that a computer program needs is to hold a basic number, right? Otherwise known as an integer. So just a basic number, and we'll just concentrate on positive numbers. So numbers from 0 upwards, and we'll stick to fairly low numbers. In other words, nothing bigger than, no, certainly nothing bigger than a million for now. So the numbers that we're going to work with will be integers, and C# has a built-in type called an int, which is short for integer. And you can see from the drop-down list here that appears, we've got various different sizes of an integer. The 16, 32 and 64 stand for bits. So in other words, the number of binary bits that can be used to make up that number. I'm not going to go into binary at this stage. Whenever we have to specify what we're going to use, we'll go with 32. We'll just go for middle of the road. But just to keep this simple, I'm just going to go with an int, or just keep it with the default. So just be referring to the keyword int. We're telling the system here to set aside a piece of memory for me that's big enough to hold an integer value. Now that memory location in the computer, which we don't have to worry about where it is, but it will have an address somewhere in the computer, and that address obviously is a machine readable address. For you to know it, for you to remember it, it's going to be difficult. So we can give it a variable, we call it a variable name, but essentially it's an alias. So it's an alias to that particular memory location. So if I was to call this number, and then with the semicolon, what I've now done is I've created a new memory location. I've told the system essentially that I want it to be big enough to hold an integer value, and I want to call that memory location number. So later on I could decide that I want to store the value 10 into number, or the value 100 into number, or whatever. Again, we're going to keep it simple here. So on another line, I'm going to assign a value to it. Now, at the minute you can see that there's like this green squiggly line underneath number, and if you hover your mouse over it, you can see it says the variable number, the variable, I should read that differently, the variable number is declared but never used. So it's just a warning letting me know that it has created memory location, but I'm not using it anywhere. Now, programs will run perfectly fine with warnings. They won't run with errors, which we will come to, but they will run with warnings. That at the minute isn't going to do anything that's visible to the user other than to press any key to continue. What I'm going to do here is, if I now start typing n for number, you can see that number is now an option on my drop down list. And if I select that, if I said number equals 99 semicolon, it's now going to assign the value 99 to the memory location that the number is referring to. Now, how would I know that that has worked? Well, what I'm going to do, I'm going to have an output line. So I'll have a console.write line. So for a shortcut, I tend to do a lot of copying and pasting. So if I change that there to console.write, press the key to continue. Instead of having that, I'll put a message that says, let's say, the value of number is, I'll leave a space there. On the next line, I'll say console dot write, and inside the brackets here, I'll just say number, and I'll end up with a semicolon. I'll run that now. And you watch the slightly strange output. So what we have again, the program starting inside this static void main. It's assigned memory location. Let's call it number. Here it says number equals 99, so it stores it in there. Next line, I'm printing out the value of number is, and you can see the message the value of number is being displayed. And here I'm saying console.write number. Now the word, or the name and number doesn't appear on screen. It's the contents that appear on screen. Now, if I was to put number inside quotes, it would take it literally and display the word number rather than the contents. So if I want something on screen, like literally on screen, I enclose it in quotes. But if I'm referring to a variable, in other words, I want the contents of something, I just refer to the variable name. Now I've used console.write. I haven't told it to take a new line or anything afterwards. So the very next thing it sees is the press any key to continue, and you can see that it's obviously stuffed right up at the end of the previous line. So if I end that and change that to a console.write line and run that, you can see it's looking better already. Now that's basic, still basic output, but using something that varies. If I was to copy those two lines and paste them in afterwards and run that, you'll see we get the message, the value of number is, the value of number is, right, twice. But what I'm going to do this time is in between the two of them, I'll say number equals, let's say 55, right, and run that. So you can see it, the first time we had the output statement, the value of number is 99. The second time we have the output statement, the value of number is 55. And that's where the name variable comes from. The memory location can vary in the contents that it holds. We've given an initial value of 99 and we've changed it to 55. You can see here the importance of the position. If number equals 99 wasn't before the first output line, well then we wouldn't have the value 99 in the variable. C# is a very forgiving language in that if we didn't have an initial value, it would put a 0 into number. Now, I can also bypass the need to do a line like that by giving it an initial value when I'm declaring it. So the output from this is going to be exact same as the output from before, 99. And here I'm going to omit, right, the use of any initializer, right, and in this case here it's telling me that I'm trying to use an unassigned local variable, so it's not even putting a 0 in there. I'll come back to that whenever I create what's called an array. As you'll see later on, it will initialize it with zeros, but in this case here it needs to have a value in it before it can be referred to anywhere. So change that again to number equals 99. So that's just basic assigning values to a memory location, essentially. The output is a wee bit long-winded there, So we'll have a wee look in the next lesson at how they change that.